So when we see the triple alligator brackets that you can kind of see in the background right here, that means that we're going to be able to type in and talk to Python. And the reason we know this is because when we load up Python, I think everybody has had a chance to do that with the TAs, we're telling our computer, okay, let's go ahead and run the Python program, essentially. And then we're speaking to Python in a language it can understand. So that's what happens when we see these triple alligator brackets. Python is essentially saying, okay, what do you want me to do? What's next? What do we want to work on? So when we see that, we're going to know, okay, in this tutorial here, we're going to use these little red highlighted kind of monospaced fonts, and that's how we're going to interact. So those are the initial things that we're going to get set up. So let's go ahead and actually start learning some basics. A quick tip, try not to copy and paste from the tutorial because that will give you exactly what is probably right. But you're going to learn a lot more from accidentally doing something wrong than you will from just copying and pasting. The number of things that you'll actually learn from that is pretty incredible because you'll make a slight mistake that you think maybe wouldn't matter, but it actually does when you're typing it out, and you're going to know, okay, well, that makes sense. I have to kind of know this weird thing. So another quick aside. So let's go ahead and actually get started. I'm going to put this on the side here, and I'm going to try, and I think this should be big enough to see both at the same time. So if it's not, please let me know, and I can definitely just focus on the terminal here. And we'll go through now. All right, so the first thing we're going to learn in Python, let's go ahead and actually make sure that we're in the Python interpreter. So is there anybody here who doesn't have a terminal open and sees those triple alligator brackets? So if one of the TAs could go over there and just help out there. If you don't see these triple alligator brackets, please raise your hand and get a TA to help you. Just raise your hand high and we'll always get a TA to help you.
Don't be embarrassed. You should see my code. It's terrible.
So, cool. So the first thing we're going to do is we're going to do some basic math. So basic math in Python looks basically identical to basic math that you would just write when you're actually just writing it out in math class. It's going to be fairly self-explanatory because you're used to some of these kind of math symbols that you might have seen before. So if we wanted to actually add things together and we're in Python, we can do something as simple as 2 plus 2. And notice here that I don't have any spaces here, so I could do 2 plus 2 and it would return 4 to me, and that's how we could do some basic math. Now I could also do 2 space plus 2, and that would also be fine. So there's a few kind of quirks there that you will notice eventually as you keep moving that you can do some things with spacing and there's other things that you can't. So we'll look at those later on. Now the next thing you can do is you can do addition with decimal numbers. So let's say I wanted to do 1.65 plus 2.15. So I could do that as well. I could add up decimal numbers, and it's just as easy as throwing a period in there for where I want the decimal to be. Now, I could do the exact same thing with subtraction. If I wanted to go, oops, I can't do an underscore. If I wanted to do subtraction, I could do 12 minus 5, and that would get us some basic arithmetic operations here. Now, let's actually take a quick look at multiplication, because multiplication is a little weirder. Instead of using maybe the X sign that we would see if we were actually writing it on some sort of math thing, we're actually going to use the asterisk symbol. And the reason for that is because the X kind of looks weird, and it's also assigned to variables sometimes, because X just sounds like if you're in math class, oh, X plus Y equals Z or whatever. So it would get kind of confusing. So we use the asterisk symbol to just kind of clarify some things and make sure we're not getting confused there. So if I'm doing this and I want to do multiplication, I could do 6 times 7. So I could go ahead and get another number out there. So go ahead and do these as you go along. Try some of these out, and go ahead and get to division, and then we'll talk about division and what we do with that as well. So if you, just keep going through and try some of those examples out. What's up?
Time in the back.
Yeah, please tell me when it's break time.
When is break time?
Yeah, I have the. You can come over here and look at it. It's on my computer. It's 3 o'clock, so I have half an hour, I think. And we may get through more or less, but we'll just keep going. So. All right, so I'm assuming you've all had a chance to kind of play around with that. If there are questions that come up, always raise your hand. So the next thing we're going to do is just quickly look at division. So division depends on the Python version that you're using, so it can be a little weird. Division in Python 2 was something called floor division. And essentially what that meant is if we tried to divide two numbers, we would just get a whole number. And in Python 3, I think they made it a little bit more intuitive, from my opinion, because when I divide numbers, I kind of expect to get whatever the actual divided number is. So in Python 3, if I go ahead and do, let's say 12 divided by 3, I'm going to get 4.0, which makes sense to me. Sure, it can give me back an integer. And if I did something like, let's say 13 divided by 3, I'm going to get back an actual decimal there that looks as close to the actual number as I wanted. Now, it would be a little bit weird in Python 2, but we're not going to worry too much about that. So basically, if we were in Python 2, we might get a different result. So if you're seeing different results, just raise your hand and we'll go ahead and get you fixed there on the version of Python. So now, in addition to division, using multiple names of operations now, so I should probably do that, not do that. We can also use something that will actually give us the whole number. So in kind of replacing what the default was in Python 2, which was to give us a whole number when we were doing division, we can do that now instead. So if I wanted to do 13, and I only wanted to get a whole number, I could go ahead in here and use these kind of basically two slashes at the same time, and it would give me back just an integer. So integers, when we're looking, these just look like an actual whole number. There's no decimals on the end, like we saw up here when we were doing 12 divided by 3. So this operation really is just saying, okay, do the division, but then throw away any remainder that we might have when we're doing that operation. So that's what that particular operator does. Now the next one we're going to talk about is one you probably maybe didn't see. Sorry, question, go ahead.
If I'm multiplying
yes.
6.2 into 9.
6.2 times 9?
Yeah.
Yes.
Can I reduce the...
Can you get rid of the weird stuff at the end? Yes, so that's a good question. So you found one of the first quirks, I guess.
For division, if I'm placing two things, it's coming down, but...
Yes, so I guess I'll answer your questions in part. There's going to be some kind of weird things that will happen in the Python programming language because of the way computers work. That's probably as much detail as I'm going to give on that, unless we're talking in a break and I get Albert in here to maybe explain why that happens. But sometimes you'll see kind of weird quirks here where Python doesn't really behave exactly like you'd expect it to. Maybe it gives you some weird ending that you don't expect. So that is a good thing to point out. I'll have a better explanation for you later on that particular fact. On how you could get rid of it and actually remove all those zeros, there are a few ways you might be able to do that. I'll also have a better explanation for you after the break. So I'm going to make Albert come up with those explanations and outsource those to him for right now. And then I'll come back and answer those questions, I promise. So the next operator that we're going to talk about is the modulus operator. So modulus essentially is getting us back to the long division that we learned in school. Instead of actually doing the division, what we're going to do with a modulus operator is get the remainder. So if I was doing some sort of operation like 16, and then we use the modulus operator 5, I'm going to get back 1. And the reason for that is because if I do 16 divided by 5, I'm going to get, okay, 5 goes in 3 times, which will get us 15, and then we're going to have 1 left over. So that's the number I want back. And it doesn't really seem clear why you would want that right now, maybe, but later on when you're working with Python and you're doing things that just having the remainder actually makes a little of sense for the work that you're doing, you'll understand it a little bit more later on. So keep that in mind. It maybe look a little weird right now, but it is helpful later on. Okay, so order of operations. So can anybody tell me what's going to happen with the difference between the 5 plus 4 times 3 on the top and the 5 plus 4 times 3 on the bottom? Any volunteers to tell me the answers to these two?
First one is 17.
Okay, let's try it. Let's do this as we go. So 5 plus 4 times 3 is 17, and then we're going to do parentheses. 5 plus 4 times 3 is 27. So that's right. So what's happening here is exactly the same thing that would happen if we were using kind of these symbols in how we would understand them with order of operations in arithmetic. We would actually evaluate what happens between the parentheses first. So in this case on the bottom, we would get 5 plus 4 first, we'd get 9, and then we would multiply by 3 and get 27. On the top, the order of operations is different because we actually use the multiplication before we do any of the other operations. So we end up getting 4 times 3, which is 12. And then once we have 12, we then get plus 5, which ends up being 17. So that's right. That's exactly what we're doing in Python as well. Python understands that and wants to make it easy for us, so it's doing the exact same thing. So the next thing let's talk about is actually types. So there's a useful function, and we'll talk more about functions toward the end of the workshop about what they are, but there's a useful function in Python called type, which lets us tell what things are, so what type of things they are. So let's go ahead and take a look at how we could use this. So I'm going to go ahead and use type, and you can follow along with me in this as well. I'm going to do type 1. So type 1 is saying, okay, this thing that we're looking at inside of the parentheses right here, this is kind of the function, the way we use functions is we have these parentheses and we give them something and they do something with it, is actually going to tell me what type of thing 1 is. And 1 is an integer, so when we get it back, it's going to tell us class int. So this means that, okay, now we know that 1, it's an int, it's an integer. And if we actually go ahead and use type on 1.0, it's actually going to tell us that this decimal that we're working with in Python is going to be called a float. So it's going to be a float that is giving us back, and that would be the same if we used, for example, like 100.0 or 120,230.0. So when we're using these type functions, it's always going to give us back what the thing is, and that becomes really useful when we're interacting with programs because it may depend on what the actual type of something is for what we can do to it. So that becomes pretty useful. All right, so go ahead and actually try the types out on your own really quick. And if you see anything weird come up, then raise your hand, but I'm going to drink water. Yes, that is a good question. So if I use type, so let's say type right here, and then I put an A in here, that's a good point, it doesn't know what to do. It doesn't understand A. So what it says back, and let me actually make this a little wider so we can see the rest of that error. So what it says is A is not defined. In Python, and we'll talk a little bit more about variables in a minute, in Python, when it sees just a letter without any quotes around it, it thinks that that is supposed to mean something called a variable. So we'll talk about strings in just a second, but if we want an actual, like maybe a sentence that we want to have and figure out the sentence, we'll use some quotes, and we'll look at that in just a sec, but that's a good point. So let's go ahead and scroll down a little bit. Okay, so functions let us do a lot of useful questions. Yeah. Date? Like if we put a date in there, you could do that. And say that again? It will give you an error. Yeah, it will give you an error. I'm assuming you just type date in between, so like type date like that? Is that what you did?
No.
Oh, you gave it like a, okay, gotcha. So you gave it like a 2018 0101 or something, or some format like that? Yeah, so that's a good question. So what's going on there is similar to what's happening with the A. It doesn't understand that particular format, and the dashes are actually also confusing it. So dates, you can have some types there that will be dates. We can cover that during a break. But that is a good thing to point out. You can have dates, you can get date types, but just typing them out like this won't let you do that. So good point. Thank you. All right. So it depends on how fast we really go, how much material we're going to get through. So I'm just kind of trying to go quickly, but I also want to answer as many questions as we can. So let me make sure I'm on track here. Okay, looks like we have a bit of extra time. So does anybody have any additional questions about this material right now? If not, I'm always just going to proceed to the next stuff and kind of work a little bit faster. So any questions that we want to dive into more on this particular material?
So in that arithmetic, can we get power? Like
can you get powers? Yes, that's a great question. So let's go ahead and do that actually. So let's do that. We might end up covering it later, but let's do it right now because it's a good timing. So if we wanted to do, say, 2 to the power of 4, and we wanted to actually do that, what we could do in terms of that is instead of doing 2 times 4 or something like that, we could actually use 2 asterisks. And this would be the syntax to say, okay, I want 2 times 2 times 2 times 2. So 4 2's in this case because we're using 4 on the end here. So if we wrote it out on, kind of math syntax, it would look like this. The little 4 over there. Sorry, my 4 is a little weird. But this is the equivalent in Python of 2. This is my poor asterisk and my another poor asterisk 4. So that's going to give us the powers that we're looking for. Does that help? Okay, cool. Feel free to use that. Go ahead.
Arithmetic expression.
Say that one more time.
In case of an arithmetic expression, if we are trying to see a Fibonacci number.
See a Fibonacci number? You would want me to write that out right now? I I could try, but I have to remember how that works. So that's another thing I'll make Albert do during the break. That's a good question. Yes, you could do that. That's a frequent question. Yeah, you got it. And and those are great things. I'd say those are. Yeah, no, absolutely. I'd say those are great things to know and definitely look at them. We can talk about them during a break, but in intro material, we're gonna skip those for right now. So I'm sorry. Any other questions back there?
Yeah, it says there's 2 minus 4 is 6.
That's a great question. So let's go ahead and do that now. So let's say the question was, when we do 2 minus 4, I'm not sure exactly how you wrote this. Maybe like that? Was that? You didn't put any spaces in? Okay, so let's leave it like this. So what's going on here? Well, there's kind of confusing stuff, right? So the minus symbol both means minus, and it also means negative. So what we're actually doing in this particular bit of syntax right here is we're saying, okay, 2 minus 4, or 2 minus negative 4. And when you're subtracting a negative number, you're actually adding the equivalent of the positive number. So it's this particular syntax is basically equal to 2 plus 4. Does that make sense? Okay, so that's a great question, because that's another thing that comes up that you might get confused by. Yes. Great. Now we get to learn so much more about arithmetic in the extra time. This is fun. Thank you for the questions. Keep them coming. All right. Well, if there aren't any more questions, I'm going to use the next few minutes to actually just jump ahead and get us through a little bit more content. So I'm going to jump ahead to part 2, and I'll rearrange some of the curriculum later on. But we're going to actually look at something called variables. So let's look at just a type of 4 right here. So type of 4 we know is an int, right? So 4 is an integer. That's why it's giving us back this int in the response here. I'm not going to really dive into what class means, but we're happy to talk about that during breaks. So what happens if we want to actually have something that stores the 4 because we want to access the 4 later? So maybe, what's your favorite number in the back there? The person who had the great question. 5. Okay, 5. So this is going to be our favorite number. I'm going to use some abbreviations, and I'm going to say it's equal 5. So what I'm doing here is I'm creating a variable called r_fav_num with these underscores in it. So r_fav_num, and I'm setting it equal to 5. So the reason I'm doing this is because we have an awesome number that we want to keep around later, and we want to be able to reference it later on, so that if we want to add our favorite number to maybe Nick's favorite number, which is
706.
Okay, we'll just go with 700. Oh, okay, okay. So we're gonna be able to do stuff with our favorite number now. So let's say we wanted to add 706 to our favorite number. So we actually defined our favorite number up here as 5, and then we used it later on to actually add it to Nick's favorite number. So we got the result of that addition. So we can create this thing, which is a variable, that we store whatever values in that we want, so we can use them later on. Now, the other cool thing is that if we do type and use the type function, we have, let's say, our favorite number hanging around, then we can actually use the type function on that to say, what is our favorite number? We don't know what it is. Let's try and figure out what it looks like. So it's telling us, okay, our favorite number right now is an int. So it lets us know kind of what we're dealing with when we're working with, sorry, what was your name in the back? You don't have to tell me, it's fine. I just wanted to thank you for your question. I'm sorry I put you on the spot. This is horrible practice for me. I just wanted to thank you for the good question. Da? Ta. Daha. Okay. Daha's favorite number over there. Then we're gonna keep using it. So that's great. We want to keep it around. Other questions about this? Yes. So cases. How do we deal with cases? Is that? Yes. So in general, yes. So let's say we wanted to use r fav num. It doesn't know what that is. Even if we wanted to do r fav num, still doesn't know what it is. If we use r lowercase fav lowercase num, it does know what it is. So yes, it is case sensitive. There is some kind of I guess protocol, not enforced protocol, but generally accepted protocol on how you would define different kinds of variables. So if I used all capitals, it would kind of mean that I want to be able to use that in more different places. That's kind of the simplified version of it. But technically these variables will work the same way. Just generally when we're using them like this, I'll probably use lower cases. And then in Python, also technically, I'm going to usually put these underscores in between the words so that I can read them a little bit better. But that's partially preference and partially convention. So, cool. Any more questions before we look at other stuff? All right. So we just looked at how to define a basic variable. So let's go ahead and actually look at what we can do with this variable. So we have our favnum now, and when I hit enter, it's just going to give us back what's in there. But let's say we want to do some other cool stuff with our favnum. Maybe we want to actually have the value 2 and multiply it by our favnum. We can do that the same way we did addition to it earlier. We can also take our favnum and we can maybe raise it to the power of something. And it's going to give us our favorite number to the power of 10. So it's going to get, apparently that is what 5 to the power of 10 is. Thank you, Python, for telling me. And then we can do a bunch of other fun stuff with it. Now, another thing that we can do is that when we're assigning variables, we can assign them with spaces in between the equal sign or without spaces between the equal sign. So I'm going to come up with just a new variable that's going to be a little bit easier for me to type, and it's just going to be x. I'm going to say x equals 5, which is still our favorite number, so we're going to just simplify this. So now whenever I get x, it's going to give me back 5. Now, I can also define other variables. So let's say I wanted to define y here. Let's say y equals 3. And I'm not going to use any spaces. Y still has the value of 3, so it still works fine, whether or not we use a space in between there or not. Now, there are some weird things that'll come up when we use some other operators, which are what we're calling these equal signs or the asterisks or other things that we're dealing with. So spaces will sometimes matter. So, okay, I think I have another 10 minutes, right?
Yeah.
Okay, cool. All right. Definitely keep me on track if I go off. Question? Yes, question. What's up?
So when you initialize the variable,
yes.
And does it give you the opportunity to initialize it?
That's a great question. So let's say x, I want to be equal to something else. Yes, thank you, thank you. So the question was, if we initialize a variable, so we say x equals 5, do we get another chance to change our minds? Maybe the favorite number in the back there has changed and it's suddenly 60 or something like that. So let's go back. I'm pressing the up arrow, by the way, when you see these things changing to go back to what I did earlier, save myself some time in case you need to do that later. So our favnum, let's say we want to actually set this equal to something else. What's your favorite number? 20? Okay, so 20. So, sorry, but now our favorite number is 20. So we do have the opportunity to go ahead and say, okay, let's take our variable, let's reassign it to something else. We do have the opportunity to do that. And that can also be something that trips us up later, because maybe we were using our favorite number and we actually did want it to be 5. So you can reassign it to things, so just keep that in mind in case you're setting it one place or setting it to one thing one place and another thing another place. So keep that in mind. Good question.
Hi, Fernando. One question from
Cool.
here.
All right. Let's go ahead and,
Hello?
yes, another question?
Fernando, Amit here
Question?
from Mexico.
You didn't want to set it to a new value, but you
So, Nini,
particular variable?
Yes.
How do you do that?
So you can delete it. I never do this, but it's DEL, right?
Yeah.
Okay. So I can get rid of it. I can just say I don't want it anymore. Our favnum, and then let's try it. Let's see if it's still there. It's not there anymore, so it's gone. So we got rid of it. So that's how we could get rid of it if we wanted to as well. We do the same thing with x, which we just defined. So now x isn't there either. If we do the same thing with y, y is there right now. Let's say DELY. Oops. Y isn't there either anymore, so we could get rid of it. You can also delete other things that exist within Python, so don't type DEL exit because I've done that before and then you just can't get out. So if I do exit and I want to get out of Python, sorry, this is a stupid joke that I came up with. So I wanted to say exit, I can get out of Python. Now I'm not in Python anymore. But if I did delete exit, I would actually be locked out for a little while until I closed my terminal and started some other things up. So keep in mind that delete can get rid of things that you might want to. So that's my caution here. Yeah, that's my, say that again.
It's gonna delete the whole class.
It'll delete whatever you're trying to delete. Yeah, it could delete a function, it could delete a variable, it could delete multiple things. So good question. Was there a question over there? Yeah. Can we create a variable without assigning anything? Yes, that's a good question. So let's go ahead and try. So let's see how we would do that as well. So let's say I want to be, let's call this nothing. Oops, I'm gonna misspell that, of course. Say nothing and let's say equals and try and hit enter. So I can't do that. So that's okay though, because we have other options we can do. We can do something called none. So none is kind of what you're looking for, I think. It might depend on what you want to do. But now if I type in nothing again, nothing happens.
So that keeps the variable in memory, but the
So nothing is a variable.
That's
So let's go
null.
ahead. Let's see what it is. Let's see what it is. That's a good question. So it's not this none type. So really, it kind of just means it's nothing.
Do you have a null?
Do I have a null? I don't think that. There's no real null.
I mean, none is pretty much.
None is basically for that, right? Okay. Yeah. So I'd say that's basically what you want. In other systems, I don't know, maybe SQL or something, you might have some null.
If the question was, if you wanted to use a variable, let's say my favorite number, and you wanted it to be a whole number, but you didn't want to assign it yet, you just wanted to say, I have this thing called my favorite number, you want to assign it later, you can't really do that.
That's a good point. So that is a good point. So
What
if,
is like a convention and say, it's nothing now, it might be something later on.
yeah, that's true.
But do you do that often or just for the sake of teaching?
I don't think I do it very, yes, I think you're right. Yes, it's kind of just to show you that it could be there. I wouldn't necessarily assign it to none very often, unless I had maybe some conditional logic where I wanted it to be none to exist and to be none, because when I say, there's something called like whether or not it's truthy. That's, I think, the best way to explain it. So it may evaluate to something that is true. So if I say, this is something we will learn later. If I say if none, if none, this is going to look like things that we will do later. So don't worry if you don't understand this. Print high. So if none, print high. This didn't work, right? If none, print high didn't work. If I wanted to do if one or basically anything else, print high. Oops, I made a mistake. Okay, so if one print high, that actually did something. So none evaluates to a no, basically evaluates to a false if you're checking for, so like if I say,
How do I actually, so should I see none as a data type or should I see it count null in SQL? Not really.
that's a good question. So the question is, should I see none as a data type or should I see none as a null in SQL, like it would be in SQL? If you're not familiar with SQL, that's fine. It could be kind of both. I'm not sure exactly how to answer. We can chat more during one of the breaks for sure, and I'll come up with a better answer, leaning on Albert as well to give me answers to all these hard questions that you're throwing at me.
Kind of true, like we.
Yes, that is what I'm trying to. That is what I'm trying to do. Exactly. So so there are things that can be kind of true. Like if I ask whether or not something. So see how we did if one here. So if we'll talk about later on. But what I was actually asking here on this first line is, okay, if something that I'm passing in after the if is kind of there, it either exists or it is true and it's not false, and basically something is there. This is a horrible explanation. Then I want to do the thing on the next line, and we'll talk about if later on, so don't worry too much about that. But if I did if none, it's kind of just it evaluates to something that is a no. It is a false. It's not going to work. That is very vague and ambiguous, but we'll try and get more into it later on.
So if you get off that question she asked,
Say that again.
you try to figure out
Yes.
back to that question.
Yes.
So right to have a list of the character and the types.
Does it have a list of types? Yes, there are like kind of types that you can interact with. So there's like ints, there's floats, there's strings, there's none type that we just saw. There's some that you will work with by default. There's also things you can kind of create on your own, and we won't look as much at the things that you can create on your own. So notice how when I was actually saying type of one, how this said class int. That means that it's the class of the thing that we're looking at is an int, is an integer. And those are some built-in types to Python. So Python has these built into it. But I could also go and write my own classes that have their own definitions and kind of work in specific ways. And those could be different types that we would get back. So I could come up with a Fernando class, and it could return to you, oh, this is class Fernando later on. So that's a good question. There is a list of built-ins. We can look at that during a break, but
Pure Python at work, or is documentation, there's a section called data types that goes through all of the built-in.
Perfect suggestion. So that'll be the best way to actually, if you want to see all the data types that are built in, we can look at Python documentation during the break and go into that. Now I only have 4 more minutes, so I'm going to go ahead and scroll through some of the rest of this variable stuff, and we'll answer a few more questions before we break. Okay, so we talked about some of this already. You had great questions, so we didn't really get a chance to go through the curriculum. So we already did some of this. Now here's a few things we need to know about variables when we're interacting with them. So be careful because you can reassign them. As we saw, we moved one favorite number to another favorite number. We also learned how to delete them, actually, which we weren't really going to look at, so that's great extra knowledge that we got, bonuses. And we also have to have a variables identifier containing letters, numbers, and underscores, potentially, but identifiers for variables have to start with a letter. So let's go ahead and try and get in here. Let's say, okay, this is 10num. So I want to call my cool number 10num. I can't do that because Python's seeing the 10 at the beginning, seeing some numbers up there, it doesn't understand what it wants me to do. And if I did something else, if I actually did num10 equals 10, that'd be fine. So the reason that it failed in the first one is because I started it with a number. So if I did something like, let's say 30 fun, this is my fun 30 number, and I can try and set it to whatever number I want, it's not going to work because I'm starting with an integer. I'm starting with a number at the front of the variable name. So that's just a convention that Python won't understand if it sees you trying to name a variable something that starts with a number. There might be questions on that. I saw a few confused faces. Okay, maybe not. I guess I misjudged. So here's some valid variable names that you see here on the right side of the screen. So any of these things over here, if you have a magic number that we're setting, a favorite number that we're setting, we can also do different things. So it doesn't have to use the underscores between the particular words that we're using in our variables. We could have capitals for the first letter of each word in a variable name. We could also, again, we could use those underscores. That's kind of what I would say is the convention for those sorts of variables, but it's not always like that, so be aware that you could see variables defined like this right here. Okay, and question, go ahead. That's a great question. We'll talk about strings, yes. So we haven't covered this very much, and we'll cover it a little bit more after the break too, because I only have 2 minutes, but let's talk about it briefly. So when you see those quotations, that usually is going to tell us we're working with something called a string. So a string is a different type. So if you see, we have this hello right here. So I'm going to go ahead and type in hello. So hello here works. We type it in with some quotes around it, and it gives us the same thing back. Notice that we have some single quotes here. That's just how the Python interpreter is always going to display a string to us. Now I can do it with double quotes, and I can do it with single quotes. And Python doesn't really care. It's always going to say, okay, that's a string, looks like a string. It's going to give me back the string. It's always going to show it with those single quotes. So you can use either one. That answered your question, right? So you can indeed use either one. So this is a string. So if we look at this underneath the type function, and we say hello, well, let's do that. It'll give us back the class of str, which is for string. And let's say we do it with the single quotes. It's going to give us back the exact same thing. It's going to say, okay, yep, it's the class string. It doesn't care which kind you use in most cases. But if we want to do something like, let's go ahead and say, I'm cool. Let's try and use single quotes to do this, right? So Python doesn't understand what we're trying to do because it sees this first quote, and then it starts trying to think about it as a string, and then it sees this other quote that's a single quotation mark, and then it's like, okay, this should be done, right? And then it sees some other stuff at the end, and then another single quote, and it doesn't know what it's doing. So it gets confused by how we're doing that. So if we wanted a string that had a single quotation in it, what we could do is actually use the double quotations, you could use double quotation marks around it, and then we would have that single apostrophe inside of the string that we're working with.